Well, welcome back, everyone. Hello, we are doing yet another fun-filled video on multiplication of decimals. Today, we're not really going to get deeper into new strategies. We're really going to focus on the fact that we have three strategies that we've been using, and like, when is it appropriate to use each one? What is it that connects best with the way that we're looking at it? So we're going to kind of talk about three phases of what we've talked about with our multiplication of decimals. We're going to talk about phase one. That's that world of estimation, how you can use estimation to help you make sense of the work that you're doing with your multiplication and finding your final product. Phase two, what happens when estimation cannot help us? Maybe it is time to think about that repeated addition or thinking about those groups that we're doing with our decimals and our products. And then phase three, which is actually kind of like phase zero, it's the beginning of all phases, but it's when base 10 shows up. Remembering that base 10 is a helpful tool and that it's here to make things simpler and not actually overcomplicate our lives. And I think often when we forget that, we get a base 10 type problem that we do in a more complicated way. So let's move back to phase one and talk about this estimation strategy. And where this comes in handy is often when you have something like a decimal like 4 and 8300ths, and let's multiply that by 6. Why estimation works in this process is that, again, you're dealing with whole numbers. Paying attention to place value in whole numbers is so helpful. In this case, even though this is a decimal, it is a decimal with a whole number. I have 4 and 8300ths, and then I have 6. So before I even get to work with my multiplication, I can use the estimation to help me. Realizing that if I think about 4 and 8300ths, if I just like round that out to like 5 wholes and I multiply that by the 6, my answer should be around 30. Now, where this is handy, this is estimation system, is that I already know then if I'm done multiplying, my 30 wholes is where the decimal is going to go. So what I'm going to do at this point is I'm literally just going to multiply, but I'm going to view this as 483, and I'm going to multiply it by 6. So whatever strategy you may have in this case for multiplying, maybe you're doing an area model, right? Maybe, I don't know why I say maybe, and then I put it up here. Maybe doing an area model, maybe you're doing partial product standard algorithm, whatever it be. I'm going to do partial products. So I'm going to go ahead and start. And I'm going to go with the 6 times 3, right? That gets me 18. And then I'm going to take that 6, I'm going to multiply it by 80. Remember that. Notice lately some of us are forgetting that. We're just calling it an 8. So that's 480. And then a 6 times a 400, which would be 2400. And then if we add these pieces together, right, we get an 8, 9, 8, 2. So if, I don't know, gosh, where am I going to put my answer over here? Answer. So if we take and we put our digits down, 2, 8, 9, 8, we know that that is the correct digits, just like you've seen on your homework. But now it's like, where does that decimal belong? And so if we go back to our estimation, we know that by estimation, we should have about 30 wholes. Well, if I put my decimal here, that gets me 2 wholes. That's not 30 wholes. I'm not into that. So I'll put my decimal here. That gets me 28 wholes. Well, that's pretty close to 30. So maybe that's where the decimal goes. But maybe I'll double check here and I'll put the decimal here. And that gets me 289 wholes, right? Right here, 289 wholes. Well, that's way too much. So I'm going to go back and put my decimal right here between the 8 and the 9, meaning 28 and 98 hundredths. That's what's going to get me my product. So again, we're estimating first to understand how many wholes we have, and then we turn around and do the multiplication itself to figure out where the decimal goes. So that's phase one, right? That's something we practiced. So if we move on, phase two, this is that repeated addition process. And where this comes in handy is when often you don't have a whole number in your decimal. Maybe I have 1 and 1200ths, and I have to multiply this by, what did I multiply by last time? 6? Yeah, let's do something different. 4, let's say 4. Now, estimation isn't really going to help me much here because this is hard to estimate. This is something, this decimal here is less than 1, right? So I could round it to 0 and I could do 0 times 4 is 0, but that's not going to help me when I actually do the multiplication on where to put the decimal. I could round this way up to 1. That'd give me 4. But that's still going to make it really hard to think about where I put my decimal, right? So the estimation doesn't really work in this case. Like I could try, but I always feel instead of wasting all that time trying to figure that out, well, let's just use another strategy. And that other strategy to multiplication is repeated addition. So when we have, in this case, a problem like 12 hundredths times 4, this is just telling me that I have 4 groups of 12 hundredths, right? And so if I was to put together 4 groups of 12 hundredths, well, that's the same thing as 12 hundredths plus 12 hundredths plus 12 hundredths plus 12 hundredths. So I'm actually, to get my answer, I'm just going to stack these up. I don't even know why I wrote linear, because now I'm going to have to turn around and erase this so I have room. So I'm going to stack these up because with repeated addition and with addition of decimals, we know that lining up the decimal is the very first thing we need to do, which allows us to know that the decimal is in the correct place. Now, again, if you've known me and watched these videos or pay attention in class, I don't like doing all 4 at once. I'm going to do 2 at a time. So 2 plus 2 gets me 4 hundredths. 1/10 plus 1/10 is 2/10. My decimal drops straight down. 0 plus 0 is 0. So that would be 2 4s. And then I'm going to do the other 2. Okay, right? So 1, 2, 3, 4. That's where that came from. And now I'm going to put together my 24 hundredths plus my 24 hundredths. And again, right, the reason we can use repeated addition is that this allows me to know exactly where my decimal goes. I don't have to do any guesswork. It's already there. So I end up with 48 hundredths. So that's phase 2. That's something to really think about. And again, think about that when you do not have any whole numbers in your decimal, because it is so small at that point. It's really hard to estimate, because would we have been able to say, oh yeah, remember what I said with that estimation? Like if we rounded to 0, well, that'd be 0. Or if we rounded it to 1, that'd be 4. Well, neither of those numbers would have helped me here. I mean, maybe I could have thought, oh yeah, well, I have 0 holes, so it would go there, but I don't know. Like that's a chance I'm not willing to take. I'd rather just use repeated addition, line up my decimals, and be correct. So that phase 2 process. So again, thinking first, phase 1, hey, I got whole numbers in both my numbers. Let me just estimate. Then I'm just going to multiply, and I'm going to use my estimation to help me put in that decimal place value. Phase 2, oh, I don't have a whole number, right? Like I have this really small decimal point. So I'm just going to stack and do repeated addition. Now, phase 3 comes along. That's a lot of relationship to phase 2, because with phase 3, what might happen is you'll still have a small, right? Maybe we have 8 hundredths, but we're timesing it by something like 1,000. Now, again, right, we can't go to estimation on this fact at all. We also could do repeated addition, but what that literally means is I'm going to have to stack up 1,000 8 hundredths, right? So that'd be 8 hundredths plus 8 hundredths plus 8 hundredths plus 8 hundredths. I'd have to do that 1,000 times. There's no time to do that. That would take forever. It would like literally take a full day to do that. So I'm not going to do that. It doesn't make sense. And again, if I try with that estimation strategy, again, I don't really know, like 8 hundredths is so small. I don't really know how to round that and then multiply. So luckily, this is just base 10. And this is the thing I want you to pay attention to, is when you're multiplying by a 10 or 100 or 1,000 or 10,000 or 1,000,000, math is doing you a favor, because at this point, you're really just thinking about what you know about place value. So let's unpack that and realize that, oh yeah, this is where I could use that resource. Remember, we have that resource where you can use the dry erase marker on the place value chart. I'm going to draw a place value chart so we see this, which is going to be fun and interesting. Let's see, we have the tenths place. No, we have the hundredths place. Sorry. So this is the hundredths. And then this would be the tenths. So those would be my decimals. I'm going to change colors as then put a decimal there as we get into whole numbers. So this would be my ones place. in my tens place, my hundreds place, and then my thousands. And I might need more. Right now I'm just putting in what I do. It's thousands. Okay, so if we think about this process here, we know we have 800. So I'm going to put that in. That's an 8 in the hundreds place. That's a 0 in the tens place. A 0 in the ones place. And then I'll bring my decimal down so we can see it. Now, when I'm multiplying by 1,000, the cool thing is I'm really just thinking about how I'm shifting place values, because one thing we know is that 1 times 8 is still going to be 8. So this digit 8, it doesn't change. It just changes its location, and it changes its location based on how many place values we have here. And with 1,000, well, I'm actually 3 place values bigger than 1, right? So this means I'm doing 1, 2, 3 jumps on my place value. So I'm going to take my 8, I'm going to jump it up 1, then 2, then 3 place values. And then I'm gonna have to do this. I could do the same things with these zeros, but one thing I noticed is as I jump this 0 here, it automatically goes to the ones place, and then it goes to the tens place, and then it goes to 100. So I don't really need that. But what I do recognize is that this is a place value I need to fill, and I can fill that with a 0, which means I'm actually going to get 80 out of this. So, oops. 0 and 800 times 1,000 actually just gets me 80. And this is that third phase, like that base 10 phase of like, how do I then realize that I'm just moving place values? And I'm actually going to just do one more of this, and then we'll kind of call it a day. And you can get moving on your practice buddy work for the day. But if we looked at another one of these examples, like I could use this place value chart, I could draw one, I could do it on paper, I could use the resource that we have in class with the dry erase markers. That's fine. Like those, use them. But if I don't have those resources by me, like remember, then we also have something like this. If I, let's do another base 10. I'll make it big for the last one, right? So we have 8,300 times 10 to the power of 5. Well, let's remember what we know about base 10. Base 10 is that this means I literally have 5 zeros. I have a 1 with 1, 2, 3, 4, 5 zeros. That comma is definitely in the wrong place. Let me fix that. Okay, let's get back to that. So 1, 2, 3. Okay, so I end up with like 100,000. So that's what we're doing here. Now, as you saw in that previous example, we could put this thing on a place value chart and shift our digits by jumping them up. We can do that. It's a great strategy. I love it. It's one of my favorite ways to do it. But if I don't have that, instead of thinking about shifting my digits up place values, I could almost think about it as thinking about moving my decimal down place values. And I know that's a little mind-boggling. So if it doesn't quite stick with you, don't panic. So if I go into this scenario, I'm looking, I have 1 place value right there. So I'm going to move this decimal 1 place value, right? So it's no longer, oh gosh, I didn't need all that. It's no longer there, right? It's now moved between the 8 and the 3. So now I have 8 and 3/10. But that's only for one of my zeros. And we have more than one zero. We can obviously see that. So if we come and count, here's our second 0. That means, again, we're going to move one more place value. So that's 2 movements. But again, now that decimal's not there. Oh, I knew that was going to happen. Let's try this again. That decimal's not there. It's now here, and we now have 83. But again, notice we have more place values. So come up here, and I see I have a third jump, which would go here, which leaves me an empty place value. So I'm going to fill that with a 0. And we also know that oh man, I'm gonna eventually get this down. That decimal is gone, right? So now it's moved here. And we have I'm gonna stop with the color changing. This is going crazy. We have a 4th, so I'm gonna jump another place value, right? And then we have a 5th, so I'm gonna jump another place value, which means I'm gonna fill these in. And if we look then, and this decimal is not here, it's moved. Oh man, you knew that was gonna happen, didn't you? Let's try that again. Cool. Let's move it all the way down here. Oh my gosh. Sorry, I keep erasing. Where was I? Okay, it's moved all the way to the end here. And then that's really what number we end up with, is that when we take 8,300 times 10 to the power of 5, we're going to get 83. 1, 2, 3. We're going to get 83,000. And that's base 10. That's how base 10 helps you out. So that's the work for today. So be thinking and being very intentional about what strategy you use for multiplication of decimals based on the numbers you're given. Do you have whole numbers? Use estimation. Do you have decimals less than 1? Then maybe use repeated addition. Or, hold on, this is fun. I got a surprise for you all. I'm going to turn this on. We have a guest. Oh gosh, look who just jumped in my lap while I was finishing this out. Say hello to the kitty. Hi, chicken. Anyway, sorry. Or as we said, do you have base 10? So that's it for today's video. For once, I actually turned the camera on. You saw my face. You saw the cat. You see my kitchen. Keep up the good work, and we will talk to you later. Remember to ask questions in class. Just because you're doing computer work doesn't mean you're on your own. So don't be afraid to ask if you're confused, because math can be confusing. Until next time.